Welcome to you guys. Today let us talk about the solution to the Northwest Regional Mocks 2024 Mathematics with Mechanics, paper number 3. Okay, so today let's just take the question 2A. So for this particular Northwest Regional Mock of 2024, the question 2A was talking about the inclined plane. Okay, so let us have the question. So question 2A. A crane of mass 50,000 kg moves up a slope incline at alpha to the horizontal. The non-gravitational resistance to the motion of the crane is 10,000 Newton. Given that the engine works at a constant rate of 1,800 kilowatt, the maximum speed of the crane is 45 meters per second, and the acceleration due to gravity is g, which equals to 10 meters per second squared. Roman 1. Find the maximum force of the engine. Roman 2. Show that sine alpha equals to 3 on 50. Okay. So let's get started for the solution of the first part. That is the Roman 1. So what do we know? We know that from P equals to FV, that is the power equals to the force times the velocity. We have known what the force will be equals to P divided by V. That is the power divided by the velocity. Now we are asked to find the maximum force. So what will you say? We say F max will be equals to what? Maximum power divided by the maximum velocity. Now take note, our power here was given in kilowatt. So to work with it here, you must convert it to what? So you have to say 1,800 times 1,000. You're going to get 180, 180, I cannot even read numbers again. Okay, you have the 1,800,000 watt. Okay, divided by what? 45. Take note, the precise data what? The maximum speed of the train is 45 meters per second. So this question was really tricky. If you don't open your eyes very well or to see or to read correctly the question, you start getting lost when you ask you to calculate maximum force. Okay, so take note, they said they gave us a maximum force and the power was constant, the work of the engine. So having that, you divide, you have 40,000 Newton. Okay, so let us take the second part now. Let us have back the question now, because now we are going to be doing real work. Okay, so here they said that what? The crane of mass is 50 kilogram. It moves up a slope incline at an angle alpha to the horizontal. So we have our plane. This is it, incline. It's moving up the slope. Okay, so that is the crane. So it's my crane. I don't look it and say it's a block. So we said that what? The angle here is alpha. So we get it. So now let us resolve the forces on this body. There's so many forces acting on this body. Okay, but let us take what are the main forces acting on this body and resolving all of them. So we get what? First we start with the weight. The weight equals to mg, the mass times g. Okay, the g, the acceleration due to gravity of the particle. So what do we get next? We get mg cos theta. So if you use your z angle theorem here correctly, you're going to see that this angle equals to this angle. Now what do you know? You know that from basis, from this following this angle, this side here adjacent is your cos. Okay, so here you're going to what you're going to have here as a force, mg cos alpha. So now if you resolve now by in the other direction, the other way, you have now an angle. Now what will be your adjacent? It will be this way. Okay, so if your adjacent is this way, now you are multiplying your cos here by mg, so it is a force. So your force will be going where? Towards this direction. So for this other particular side here, using our z angle theorem, we have mg cos theta cos alpha to be acting this way. So now let us take the other component, mg sine alpha. Still on our z angle theorem, we have what? The opposite of that angle to be this way. So the force will be what? Mg sine alpha. We now go and take the direction of motion. That is, this is the force acting the body. Now next we have what? We have the non-gravitational resistance. Take note, they said there was a non-gravitational resistance. Now after that, now we now have R, the normal reaction force, because the body, the crane here is on the floor and it's moving, so there's a normal reaction force. Okay, so having that, now let us take now the other part. Okay, let us choose our direction of motion. We have this as our direction of motion. So having this now, what we now say, we now have to show that what sine alpha equals to 3 on 50. Okay, so let us take the solution. So what do we see? We said at equilibrium, some forces will be equal. So you have what? F to be equals to mg sine alpha plus the non-gravitational resistive force, that is F following the motion, okay, will be equals to what? Mg sine alpha plus ngr. Okay, resolving this force, the forces at equilibrium. So now having this, now we pass to the next part. We now make what? We now have to make sine alpha the subject to have the proof. Okay, so doing that, we have sine alpha to be equals to F minus the non-gravitational resistance all over mg. Now we simplify further and we replace our value for F, NR, NGR, and MG, and you see the proof will come out. We calculated F to be equals to 40,000 minus 10,000, you get 30,000 divided by what? MG, which is 50,000, which is 500,000. Yeah, 500,000 Newton. That is M times G. The mass was 50 and G was given to be 10. So you have the proof come out to be 3 on 50. So now having that, you get the proof, and that is all for the video. So I thank you all guys for watching, and I hope you people understood something today. I hope you people can now resolve the forces on this diagram. Okay, so see you guys in another video. Don't forget to comment, to like, and to share. So thank you.